Good morning, Tahmina Khan is here in TKMaths is Fun. In today's video, which is in continuation of complete lessons on M1 A-level mathematics, we are on lesson 4, which is force and Newton's laws of motion. So this is video 4.4, which is basically past paper questions. The rest of the videos are already, you can see the link in the description below. So let's continue. We will do these two past paper questions. So first question is here, if you want to try out yourself first, you can put the video on pause and do it. So I will start explaining and solving. First question I'm explaining and second will be test for your understanding, and I have solved it already, right? So let's see here. Two particles A and B of mass is 0.4 kg and 0.2 kg are respectively connected by light inextensible string, and we can see it in the diagram. They are hanging freely. Both A and B are 0.5 meter above the ground. The particle hangs vertically. The particles are released from rest. Important information. If you need to apply SWOT equation later, then U will be 0. In the subsequent motion, B does not reach the pulley. A is heavy. When you will release it, definitely this will come down and this will go up. When it will reach here, it would have covered distance 0.5 meter, and at the same time suppose B is somewhere here and it would have covered the distance 0.5 meter, right? What is question saying? Let's read. In the subsequent motion, B does not reach the pulley and A remains at rest after reaching the ground. So it is telling you that once A will reach here, and of course B will go up and then come down. The question is, when it is going up, right, after reaching this point also, definitely it will be in motion, it will go further up. It will not reach here. This is what question is saying. It does not reach the pulley and A remains at rest. Now, part 1. For the motion before E reaches the ground, show that the magnitude of the acceleration of each particle is this and the tension in the string. So this is exactly what we have done. We will make here two separate equations for particle A and particle B according to Newton's second law of motion. So let's do that. So for particle A, now we will follow F is equals to ma, which is Newton's second law. So A is coming down. So it is 4 minus T is equals to, what is the weight? 0.4. 0.4a. This is my equation 1. Then for particle B, now B will go up. So there is tension and here is weight, which will be 2 Newton. And in this case it is 4 Newton. So now because B is going up, so T minus 2. Okay, so it will be T minus 2 is equals to 0.2a. This is equation number 2. Now you will solve equation 2 and 1 simultaneously. So you can add up two equations. So it will become what? 4 minus T plus T minus 2 is equals to 0.4a plus 0.2a. So it will become 6 is equals to 4 minus 2 is 2. Blunder, just a minute. So it is 2 is equals to 0.6a. So a is equals to 8 upon 3 or 2.66 meter per second square. So I got the acceleration. Question is saying find the tension in the string as well. So this value of acceleration you can plug in either in equation 1 or in equation 2. So let me substitute it in equation 2. For example, I'm mentioning where I'm substituting it here. So it will be T minus 2 is equals to 0.2 8 upon 3. Right? So now it will be 2 divided by 0.6, just a minute, I think. Oh, it is not 8 upon 3, it is 10 upon 3. 3 2s are 6. That is right. So it is 10 upon 3. Okay, so this is what we have to prove also. So it is right. So t is equals to, now add it up. 2 plus 2 divided by 3 is 8 upon 3. So tension is 8 upon 3 Newton. Second part of the question is find the maximum height of B above the ground. Okay, so let me come back here to the question and then I will start explaining here. Okay, so let's see here what happens. Let me erase all this. Okay, so what happened? This is 2 Newton here and this is T. Now it is going up, right? B is going up and A is coming down from here to this side, and this distance is 0.5. So when B will go up, for example, B reaches here and this distance will be 0.5 meter. That is the time when A will hit the ground. Now question is saying maximum height, because it is already given here that B will not reach the pulley. It means after that when B will start moving up, it will stop somewhere before reaching to the pulley. What does this mean? At this point when it will reaches here, velocity will be 0, because after that it will start coming down back. At this time from here to here, the string will be slack, because now there is no tension. A is on the ground already. So what will happen at that time? A will be minus 10, because now it is under the free fall. Okay, I hope you understand. So now B is here and B has to go up, string slack. It will stop here at V equals to 0. During this time A is minus 10. We have to calculate what is the distance at that time. At the same time, what is the velocity here? This will be same as the velocity of A here at the ground, because when velocity object A is on the ground, that is the same velocity B will have it here. Okay, so let's calculate this velocity first of all. Okay, so I am writing here when A reaches the ground, its velocity. Okay, because that is the same as the velocity of B at that time. Its velocity is, so let me calculate with respect to A only. So I am calculating with respect to this. U is equals to 0, because initially both particles were at rest. V I have to calculate. A we have just calculated, it was 10 upon 3. And what? SWOT equation will be V square is equals to U square plus 2AS. Yes, and S is equals to 0.5, which is given to us in the question. So now I'm substituting the values here. This I have to calculate. U is 0. Please pick up the calculator. Okay, I have just substituted the values from this point of particle A. So now V is equals to root 10 upon 3 or 1.8257 meter per second. Now let's see here. It means this velocity is 1.8257. Now I will use all this information which is given here, and I will do what? Find out the distance. Then I will add distance 0.5, 0.5 and that distance. Okay, because this is 0.5, this is 0.5 and this distance I am calculating now. So let's do it. For particle B, U is equals to 1.8257. You understand this? V will be 0, A will be minus 10, S we have to calculate. So it is V square is equals to U square plus 2AS. it is, I'm just using exact value to avoid any 2 decimal or 3 decimal errors. Okay, so S is coming 20, S is equals to 10 upon 3, S is equals to 1 upon 6. So total height of particle B above the ground is 0.5 plus 0.5 plus 1 upon 6, which is equals to 7 upon 6 meter. So I hope you understood this question. If you have any question, you can ask in the comment. And now I'm showing you the next question, which is from November 16, variant 4.3. I've already solved this question. You can put the video on pause and try it. So I'm showing you the solution here. I'm showing you slowly, one thing at a time, so you can tally it with your working. As I said, it is very important that you mention all the forces in the diagram first of all to avoid any confusion. After that, I have made 2 equations of the motion, and then I'll solve them simultaneously, just like the previous question, and find the value of tension and acceleration. Then to solve the second part, because question is saying determine whether Q comes to instantaneously rest before reaches the pulley directly above it, here or not. So of course I need to know the velocity first of all when P reaches the ground. So when P will come here, definitely Q will go up here and it would have covered distance 0.4. So what is the velocity of Q here is the same as the velocity of P here. So this is what we have calculated here. After that, what distance is left? 0.1 meter, right? So now we will see what is the distance covered when velocity is 0 for particle Q. That is the way we will calculate it. I have tried to written it down everything clearly so that there is no confusion. If my distance will be less than 0.1, it means particle Q will come to rest, instantaneously at rest before reaching the pulley. But if my distance is more than 0.1, it means it did not stop. Here I drew the diagram. And what is distance coming? 0.16, which is more than 0.1. So what does this show? That Q will not come to instantaneously at rest before reaching the pulley. So I hope you understood. I will make more videos on pulley question. There are many questions, but let's first complete the concept of resolving forces and friction in next videos. Then we will come back to pulley question. So thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.